Hi everyone, I'm really excited that you are able to join us for this uh, 2020 edition of the SpaceApps Challenge. My name is Abhishek Chatterjee. I'm a carbon cycle scientist at NASA Goddard Space Flight Center. And what I'm going to introduce today is a challenge that we are calling Measuring Your Carbon Footprint. Now, before we get into the details about the challenge, I would like to give you some background about carbon cycle science, about the different NASA and other partner space agency satellite missions that we have in orbit that are monitoring the atmospheric carbon dioxide and methane concentrations, and then a short introductory video by Dr. Berrien Moore, who's PI of one of the future satellite missions that will be launching soon, called GeoCard. So here we go.
Our atmosphere, just a thin layer of gases surrounding our planet, absorbing solar radiation, retaining heat to warm the Earth's surface. A delicate mixture of gases separating life on Earth from the rest of the cosmos. But when this mixture of gases gets out of balance, the temperature rises and alters our climate. Carbon is an essential component of Earth's atmosphere, but it's also the primary driver of our warming climate. And NASA scientists are learning more by studying how carbon dioxide moves through the atmosphere, ocean, and plant life. When people burn fossil fuels and clear forests, carbon dioxide is released into the atmosphere. But only half of that carbon stays in the atmosphere, warming our planet and contributing to climate change. The other half is removed from the air by the planet's ecosystems and ocean.
A huge question is, in the future, as the carbon dioxide builds up, will the land and the ocean continue to take up that 50%? Do they get saturated, they're full, and they quit at some point, or do they always just take up more and more and more? The key motivation for the OCO3 experiment is to continue this record of carbon dioxide. OCO2 was built to last 2 years. We've had it up there for 4 years, but there's always a risk it's not going to survive. So OCO3 goes on the space station in the spring. We'd like to have measurements that cover a long duration, and OCO3 is going to help add to that record.
OCO3 is going to specifically produce a data set of carbon dioxide measurements. We'd like to be able to keep an eye on this atmospheric CO2. Where did it come from? Where is it going? And how is it related to other global processes?
Hello, I'm Berrien Moore, and I'm at the University of Oklahoma. I'm also the principal investigator on NASA's latest Earth Venture mission, the Geostationary Carbon Cycle Observatory, GeoCarb. This mission is going to go after one of the critical questions in the carbon-climate connection, and that is, why is there this weather variability between the emissions of carbon dioxide and the uptake of carbon dioxide over the terrestrial landscape? This is something that we really don't understand, and it's critical that we understand the processes that are causing that variability. The variability seems to be occurring at weather timescales, and therefore, if you want to understand something that is changing on weather timescales, we need to be on a weather satellite-like orbit, a geostationary orbit. We're going to be mapping carbon dioxide and methane at 3-mile resolution every day over the Americas, wall to wall. Stay tuned, we're going after a big problem. Thank you.
So, what are you supposed to do for this particular SpaceApp challenge? Well, as the description says, it's all about measuring your carbon footprint. How do we look at the carbon footprint? Well, any and all activities that we do around us, daily activities from driving or from land use change or from agriculture and industrial, all of them release some amount of carbon dioxide and methane emissions. The challenge for you would be to look or take stock of those daily activities, look at the different measurements that we are collecting using different types of satellite or remote sensing sensors, and then try to come up with an estimate of what those emissions are. So for example, I'm standing in this beautiful forest right here, but let's say if you were to cut down all the trees and convert this land to do agriculture, then that would result in a large amount of emissions. Can you, using different types of tools, using the measurements that we are taking, and the different types of sensors, are you able to come up with an estimate of those emissions if this land were to be converted? So that is a challenge for you, and that's where we are really excited that you are participating in this program, and we look forward to your contributions and your questions. Thank you.